Hello students, in this video we are going to discuss to Cbse class 9 physics NCERT science textbook chapter 8 motion, the 15th part. We are going through this lesson motion, and we have started with the derivations of equations of motion in the previous video in part 14. Okay, so in this video we will be seeing the next derivation, that is the position time relation. This is the second equation of motion. The previous one which we saw was the velocity time relation. Okay, what was it? It was the velocity time relation, and or it was called the first equation of motion, and it was nothing but v is equal to u plus at. Hope you all remember this. If you have missed looking into this video, please get back to that video and go through it. So now we know that there are three. The first one is a velocity time relation, which we have already discussed. V is equal to u plus at. In this video we are going to discuss this position time relation. This will be seeing in the next video, that is the position velocity relation. So when we are discussing the equations of motion, we all know that this consideration is the same for all the three equations of motion. We are considering an object having an initial velocity u. Okay, there is an initial velocity u and it's subjected to a uniform acceleration a and reaches a final velocity v. Okay, so this happens throughout a time t. Okay, this happens throughout a time t, and in this it is going to cover a distance. Yes, is it clear? So when we are considering this graph, we are getting all these considerations. That is, this OC will be equal to AD, which is equal to AB, which is equal to T. Okay, that is this T. And then OA is equal to CD is nothing but U. And OE, the entire OE is equal to the entire CB, which will be V. Okay, and then we will see that AE will be equal to what? The entire V minus this portion, that is U. So that is what we are seeing here. Now we will get into the position time relation. See, as I said, it is talking about the position. What does position mean? Position talks about the distance. Okay, so we are talking about the distance. How can we get distance from the velocity time graph? By calculating the area. Okay, so we are going to calculate the area for both the second and the third equation of motion. So have this in mind. Okay, so my area will give me the area under AB, that is the slope AB, will give me the distance. Okay, distance, that is S. So now what is this area? Area of the trapezium OABDC. OABDC. So this is a trapezium. I can divide this into a rectangle OADC and a triangle ADB. Okay, so I'll have to calculate it separately. What will be the, so for both we can calculate the area of the rectangle and area of triangle. What will be this? So we are going to add these both later on. So what will be the area of the triangle first? So let me do that separately. Area of triangle OADC will be equal to OC into CD. So OC we are having here as T, CD are having it as V. So it will be T into, so T into, sorry, CD is here, that is U. So T into U, which is nothing but UT. Okay, next we are going to find out the area of the, so this is not triangle, this is the rectangle. So area of triangle ADB, which will be half into base into height. So when I am going to consider this triangle ADB, so my base is what? AD, and my height is BD. So it is half into, what is AD? AD is what? T, and BD is what? V minus U. Okay, so T into V minus U. So what did I tell you? S is the, so we saw just now that S is the area of this plus this. So it will be UT plus half T into V minus U. Okay, remember carefully children, till this it is going to be the same for both second and the third equation of motion. Got it? So what is same till? S equal to UT plus half T into V minus U. So S is equal to UT plus half T into V minus U. So what do I do next? Next we are going to look into the heading. What is this position time relation? Okay, you need to have position and time priority in this derivation, but we have a lot of velocity also. And we already know that, okay, so we already know that we will be able to get the value of V minus U, okay, from the first equation of motion. So what did we have? V is equal to U plus AT. So I can say V minus U is equal to AT. So can I substitute that here for V minus U? Yes. So what will I get now? I'll get UT plus half T into AT. So what will I get? S is equal to UT plus half A. T into T is what? T square. And this is the second equation of motion. See here you have position and time. Position is nothing but S and time is nothing but T. You are having that more priority in your second equation of motion. Is it clear children? Sometimes you will always get confused with position time relation and position velocity relation. So in that time you should remember that you have more of time in the second equation of motion, that is your position time relation. Okay. So let's do a quick recap here. Let's go through this. So area under the VT graph will give the distance covered. Okay. So distance equal to area under the line AB, which will be OABC. Okay. So that will be area of the rectangle OADC and triangle ABD. So for area of the rectangle, OA into OC, triangle half into AD into DB. So substitute those values for this V minus U. You are substituting it to be AT. You can also take it from here, where this is the formula for acceleration also. Or you can take it from V is equal to U plus AT also. Both are going to be one and the same. Okay. So thus we are going to get this S equal to UT plus half AT square. So and this is called the position time relation or the second equation of motion. Is it clear children? Yes. So hope you understood this. So thus we are completing with the second equation of motion. The first equation of motion is already done. Please get to the link and then check through it. In the next video we will be doing the third equation of motion or the position velocity relation. It's yet another very easy equation of motion to derive also. Okay. So see you again in another video. Thank you children.